Carbide burrs, essential tools for grinding, shaping, and deburring in workshops worldwide, can contribute to environmental strain through generated dust, material scraps, and discarded tools if not handled sustainably. But adopting eco-friendly practices transforms them into allies for greener operations by minimizing waste and airborne pollutants. These tungsten carbide attachments, while durable, produce fine particulates during use that pose health risks and ecological harm if dispersed unchecked, such as contaminating soil or water when improperly disposed of. However, by integrating thoughtful strategies like efficient dust collection and burr recycling, users can significantly reduce their carbon footprint and promote resource conservation. This article explores these practices in depth, offering practical tips and verbal guidance on techniques that curb material waste, emphasizing how small adjustments in daily routines yield substantial environmental benefits, from cleaner air to extended tool lifespans that lessen the demand for new manufacturing. One cornerstone of eco-friendly carbide burr use is implementing proper dust collection methods, which directly addresses the generation of hazardous airborne particles that can linger in workspaces and beyond, contributing to respiratory issues for workers and broader atmospheric pollution. When a burr engages materials like metal or wood, it shears off microscopic chips and dust, often containing heavy metals from carbide or alloys that, if left to settle, can infiltrate ventilation systems or outdoor environments, exacerbating issues like particulate matter in the air that affects ecosystems and human health, according to guidelines from environmental agencies like the EPA. To mitigate this, start by attaching a shop vacuum or dedicated dust extractor directly to your rotary tool via a flexible hose, ensuring the system features HEPA filtration to capture 99.97% of particles as small as 0.3 microns, far superior to basic masks alone. For handheld die grinders, opt for models with built-in extraction ports, and always position the collection unit downstream of the cut to suck away debris in real time. Verbal advice here: before starting any project, test the setup by running the tool unloaded and observing airflow. Adjust the hose diameter to match the tool's exhaust, typically 1 to 2 inches, to maintain suction without restricting movement, and empty filters regularly into sealed bags for disposal, preventing re-release of captured dust. This method not only minimizes airborne particles, reducing indoor pollution by up to 90% in enclosed spaces, but also prevents dust from embedding in workpieces, which could otherwise lead to secondary waste during cleaning. The eco-impact is profound, as it curtails the release of respirable silica or metal fines that contribute to smog formation and soil contamination when washed away by rain. Recycling worn carbide burrs stands as another vital sustainable tip, countering the mining-intensive production of tungsten carbide, which involves energy-heavy extraction processes that deplete rare earth resources and generate mining waste equivalent to thousands of tons annually worldwide. As burrs dull after 50 to 200 hours of use, depending on material and technique, they often end up in landfills, where the non-biodegradable carbide persists indefinitely, leaching potential toxins over time. Instead, recycling programs, available through tool manufacturers or specialized facilities, reclaim the tungsten for reuse in new tools, conserving up to 95% of the raw material and slashing emissions from virgin production, which can account for 20 to 30 kilograms of CO2 per kilogram of carbide. To implement this, inspect burrs periodically for wear signs like rounded flutes or reduced cutting efficiency, and when irreparable, clean them thoroughly by soaking in a non-toxic solvent like citrus-based degreaser to remove residues, then package them securely for shipment to certified recyclers who separate the carbide via crushing and chemical recovery. Verbal guidance: maintain a dedicated bin in your workshop for retired burrs, labeling it clearly to encourage consistent drop-offs, and research local or online recycling services that offer prepaid labels. Many accept mixed metals without fees, turning what was waste into a cycle of renewal. The environmental ripple effect includes reduced deforestation from tungsten mining in sensitive habitats and lower energy demands in recycling versus extraction, fostering a circular economy that aligns with global sustainability goals, like those in the UN's Sustainable Development Agenda. Efficient techniques to reduce material waste during Carbide Burr operations further enhance eco-friendliness by optimizing cuts that preserve resources and minimize scraps destined for incineration or landfilling, where metal and composite wastes can release greenhouse gases through decomposition or processing. Waste arises from over-aggressive removal or imprecise paths, generating excess shavings that, while recyclable, still require energy for melting and reforming. To counter this, adopt a layered approach to shaping. Begin with light scoring passes at 50% depth to map the contour, gradually increasing removal in subsequent layers, which can cut waste by 40 to 60%, compared to single deep dives that often overshoot and necessitate rework. Verbal advice: always sketch your project outline on the workpiece with a washable marker, using it as a guide to follow tight, controlled arcs with the burr rather than broad sweeps, and incorporate frequent pauses every 10 to 15 seconds to assess progress and clear chips, preventing binding that leads to unnecessary gouging. For metals, pair this with appropriate speeds, 15,000 to 25,000 RPM, and feeds, 1 to 2 inches per second, to shear cleanly without tearing, while for woods or plastics, lower to 5,000 to 10,000 RPM to avoid splintering or melting that creates unusable debris. This precision not only saves material. Imagine salvaging enough aluminum scraps from a bracket project to recycle into new stock, but also reduces energy consumption in the tool itself, as smoother operations draw less power. The broader eco-impact involves diverting tons of potential waste from landfills annually, conserving natural ores, and lowering the embodied energy in products, ultimately supporting biodiversity by easing pressure on mining operations that disrupt habitats. Integrating these practices, dust collection, burr recycling, and waste minimizing techniques, creates a holistic eco-strategy for carbide burr users, transforming routine tasks into environmentally conscious endeavors that yield both personal and planetary benefits. By prioritizing HEP, A-filtered extraction, you safeguard air quality and health while complying with workplace safety standards. Recycling ensures scarce resources like tungsten circulate rather than accumulate as pollution. And efficient cutting preserves materials, cutting down on the 1.5 billion tons of global e-waste projected yearly. Verbal encouragement: start small by auditing your current setup for 1 week, tracking dust output and waste volume, then implement one tip at a time, perhaps adding a vacuum hose first, to build habits that feel natural and rewarding. These steps not only extend the usability of your tools, but also contribute to a sustainable workshop culture where precision meets responsibility, reducing the hidden environmental costs of craftsmanship and paving the way for innovative, low-impact fabrication in an increasingly resource-conscious world.